Just 4 light-years away, a mere cosmic stone's throw, lies Proxima Centauri. It's our closest stellar neighbour, a small, dim red dwarf star, far different from our own Sun. Orbiting this star is Proxima B, a rocky planet residing in the habitable zone. This is the region around a star where temperatures are just right, allowing liquid water to potentially exist on the surface. This remarkable discovery makes Proxima B one of the most intriguing and potentially significant worlds ever discovered beyond our solar system. Its proximity piques our curiosity and fuels our desire to understand its nature. We can only imagine what it would be like to stand on its surface. Picture a sky tinged red by the light of its dwarf star, a world of extremes shaped by forces vastly different from those on Earth. The environment could be both alien and strangely familiar. Proxima B is tidally locked, meaning one side is perpetually facing its star, bathed in endless day, while the other side remains shrouded in perpetual night, a realm of eternal darkness. But along the terminator, the twilight zone where day meets night, conditions might be just right, a delicate balance that could potentially support life. This sliver of perpetual dawn or dusk, a band of constant twilight, could be a haven, a habitable zone where life could potentially thrive and evolve. Proxima B has quickly become a prime target for our most powerful telescopes, both on Earth and in space. For years we watched and waited, collecting data and refining our models, hoping to unravel its secrets and understand its true potential. We knew it was there, a rocky planet only slightly more massive than Earth, orbiting its star at a close distance. But despite our knowledge of its existence, its true nature remained hidden, a tantalizing enigma. Our instruments, while powerful, simply weren't powerful enough to directly see its surface features or analyze its atmosphere with sufficient clarity. The distance was a significant hurdle. We were like children peering through a keyhole, straining our eyes to catch only a fleeting glimpse of the room beyond, never able to fully grasp the whole picture. We desperately needed a better eye, a more advanced tool, a next-generation telescope to finally reveal what lies on the other side of that cosmic keyhole. The mystery of Proxima B has fueled our imagination, ignited our curiosity, and driven our scientific ambition. What secrets does our nearest neighbour hold? Is it a barren wasteland or a hidden oasis teeming with life? The search for answers, the quest to understand Proxima B, was about to take a giant leap forward thanks to groundbreaking advancements in telescope technology. To unlock Proxima B's secrets, we needed a new kind of telescope, the James Webb Space Telescope. Webb is more than a telescope, it's a time machine, capturing faint whispers of light from across the universe. Its infrared vision lets it see through cosmic dust, revealing what other telescopes cannot. Webb can analyze the chemical makeup of distant planets' atmospheres. That's why it was chosen to study Proxima B. Time on Webb is precious, but the allure of our nearest exoplanet was irresistible. The plan observed Proxima B as it transits its star, using transit spectroscopy to search for atmospheric gases like water vapor, methane, or oxygen. On a carefully scheduled day, Webb turned its golden mirrors toward Proxima Centauri. Data streamed back to Earth, carrying the promise of answers. Scientists prepared for years of analysis, searching for subtle clues. But what they found was something no one expected. The universe was about to surprise us. Observing a distant exoplanet light-years away is a monumental task. It requires the most advanced technology and unwavering dedication. It demands patience and precision as scientists meticulously sift through vast amounts of data, searching for the faintest of signals. Every photon counts in this cosmic quest. Webb, with its unparalleled capabilities, collected light from Proxima B, a planet orbiting our nearest stellar neighbour. Scientists were hoping to reveal its secrets, to understand its potential for habitability, and perhaps even to find signs of life. Scientists broke down the light into its constituent colours, searching for chemical fingerprints, the telltale signs of various elements and molecules. They were looking for signs of an atmosphere, a protective blanket that could shield the planet's surface, maybe even life, or at least the building blocks of it. The possibilities seemed endless. At first, the data looked normal, a steady stream of information that conformed to expectations. But then something strange appeared, a deviation from the norm, an anomaly that caught their attention. Concentrated, intermittent bursts of light emanating from the planet's night side, a region shrouded in perpetual darkness. These weren't random flashes like lightning, the kind of atmospheric phenomena that are common on many planets, or volcanoes spewing molten rock and ash into the atmosphere. The lights had a pattern, a rhythm, a structured sequence that defied simple explanation. Appearing in a specific area, pulsing with an almost deliberate cadence, then vanishing without a trace, only to reappear moments later in the same location, repeating the cycle. Proxima B's dark side should be cold and lifeless, a frozen wasteland inhospitable to any known form of life. Yet here was undeniable evidence of energy and light, defying all expectations and challenging existing scientific models. The team checked for errors, scrutinized every data point and double-checked their calculations. They ran diagnostics on the instruments, ensuring that there were no malfunctions or spurious signals, and ruled out every alternative explanation one by one, eliminating any possibility of a natural phenomenon. The conclusion was inescapable. The data was valid, the signal was real. The lights were real, undeniably coming from Proxima B, a planet that should have been shrouded in darkness. No natural explanation fit the data, leaving scientists baffled and intrigued. The control room shifted from quiet focus to awe, a palpable sense of wonder filling the air, and confusion as they grappled with the implications of this extraordinary discovery. What could create such a signal in the darkness? What unknown forces were at play on this distant world? The mystery deepened with every passing moment, drawing them further into the unknown. Humanity had glimpsed something truly extraordinary, a potential game-changer in our understanding of the universe. The search for answers had only just begun, and the journey promises to be filled with wonder and discovery. In the control room, an almost palpable silence descended as the team stared, transfixed, at the data unfolding before them. Every blink, every breath seemed amplified in the sudden quiet. These scientists were seasoned professionals, accustomed to the slow, methodical pace of scientific discovery. The incremental gains, the painstaking analysis, but this was different. This felt like a leap, a sudden, unexpected jump into the unknown. The graphs, usually abstract and complex, now told a clear, undeniable story. Something somewhere on Proxima B was generating light, and not just any light, but a structured, patterned emission. Initial disbelief, a natural defense against the impossible, quickly gave way to a burgeoning excitement, a hesitant hope. That excitement then morphed into a humbling sense of awe, a profound understanding of the sheer magnitude of what they might have stumbled upon. If the lights weren't the product of some natural yet unknown phenomenon, then they had to be artificial. And that possibility, that single earth-shattering possibility, was staggering. The implications rippled outwards, touching every corner of human understanding. We might not be alone. The universe, once a vast and silent expanse, might suddenly be filled with voices. The team, acutely aware of the gravity of the situation, immediately secured the data, backing it up on multiple systems. They brought in trusted experts from around the globe to meticulously verify the findings. News of this magnitude couldn't be rushed, couldn't be sensationalized. It had to be handled with the utmost care and precision. In those first frantic hours, fueled by coffee and adrenaline, the scientists felt the very foundations of history shifting beneath their feet. They had peered into the darkness, and they had seen a light. Nothing would ever be the same again. The discovery, if confirmed, would force humanity to confront its place, its purpose, in the vast cosmic tapestry. Are we truly alone, adrift in a sea of stars, or is there someone else out there, gazing back at us, wondering the same thing? The world would soon demand answers, demand explanations. The journey into the unknown, a journey that had begun with a single flicker of light, had truly begun. Science demands that we exhaust all ordinary explanations first. The team considered every natural cause. Stellar flares, volcanic eruptions, even super-auroras. Could minerals fluoresce under stellar energy? Could volcanoes light up the night side? Each idea had problems. The lights were too regular, too structured, too localized. Volcanic eruptions and auroras are chaotic, not rhythmic. No natural explanation fit the data perfectly. The list of possibilities grew shorter, the mystery only deepened. The evidence seemed to point towards something far more profound. When natural explanations fail, scientists must consider the extraordinary. Could the lights on Proxima B be artificial? Evidence of alien technology? The regularity and concentration of the lights matched what we might expect from a city. Imagine a civilization living on the dark side, using technology to create warmth and light. The lights could be massive population centers or energy grids. This hypothesis is speculative, but it fits the data better than any natural cause. If true, it would mean we are not alone. The implications would be staggering. A cosmic neighbor just 4 light-years away. Humanity's place in the universe would be forever changed. For now, it remains a tantalizing possibility. The search for proof continues. The lights on Proxima B highlight the central question: how do we search for life beyond Earth? Astronomers look for biosignatures, gases like oxygen and methane in a planet's atmosphere. The James Webb Telescope was built to find these clues. SETI searches for technosignatures, evidence of technology like radio signals or city lights. The lights on Proxima B could be a new kind of technosignature planetary engineering visible across space. This discovery broadens our perspective. Alien life might not just whisper through radio waves, it might shine a beacon in the darkness. The search for cosmic company has entered a new era. The mystery of Proxima B's lights remains unsolved. More observations and data are needed. Scientists worldwide are now focused on this nearby world. Something fundamental has changed. A door has opened that can never be closed. This discovery is a testament to human curiosity and our drive to explore. Telescopes like Webb are extensions of our senses, reaching for the stars. Whether the lights are natural or artificial, we have learned something new. If they are a beacon, we stand on the edge of a new era. The search continues, filled with hope and questions. The journey of discovery has only just begun.